Good evening, sir.
Good evening, sir.
Shall we start, sir? Shall we start, sir?
Okay, sir.
Dear sir, madam, so we are in fifth day of ATAL online 6-day faculty development program on design for manufacturing and advanced automation for industry 4.0. And today's speakers from overseas, Dr. Hari Prasad Rao Payadi, Associate Professor, Department of Mechanical Engineering, College of Engineering and Technology, Blue Hara University. In the title, IoT in Manufacturing, Leveraging Data for Smart Manufacturing. Now I invite Mr. Vignesh, Assistant Professor, Department of Triple to introduce our esteemed resource person.
I'm delighted to introduce today's speaker, Dr. Hari Prasad Rao Paidi, working as an associate professor in Department of Mechanical Engineering at Bull University, Bull, Ethiopia. He secured a PhD in the Department of Mechanical Engineering at Acharya Nagarjuna University, Guntur, Andhra Pradesh, India. He is in the field of mechanical engineering at Bull University, Bull, Ethiopia. He is an experienced and dynamic individual with a strong academic background in mechanical engineering. Dr. Hari Prasad Rao Paidi, giving his teaching and research service to different national and international universities more than 15 years and passionate about research, believes in learning, striving for enhancing skills. He has presented 25 research articles in national and international journals, conference, symposiums, and also published 4 textbooks and 4 patents in the field of mechanical engineering. He serves as a reviewer for academic journals and textbooks in the area of mechanical engineering. He has developed innovative courses integrating advanced researches, methodologies, hands-on laboratory experiences. Dr. Hari Prasad Rao has served in numerous educational institutions as a dependent head, examination cell in charge, and pre-engineering coordinator. Now I hand over the session to Dr. Hari Prasad Rao Paidi.
Okay, sir. No.
Hi, sir. Hi, sir.
Hi, sir. How are you?
I am fine, sir.
Now, okay, na, sir?
Not visible, sir.
Not visible?
Yes, sir. Yes, sir. Yes, sir.
Okay, sir.
Can in slideshow, sir?
Okay, sir. Okay, sir. Thank you very much for giving this wonderful opportunity. I am thankful to your institute by giving these opportunities. I myself, Dr. Hari Prasad. I work various universities in Ethiopia past 15 years as an associate professor. Now I can start my already professor given me about my details. I can start my presentation directly. IoT manufacturing, leveraging data for smart manufacturing. Nowadays, everything collaborating with AI, machine learning, and data science, IoT, Industrial 4.0. Introduction to IoT in manufacturing. IoT combines sensors, devices, and data analysis to transfer the manufacturing. By integrating all sensors and analytics, IoT modernizes manufacturing process, enabling intelligent, data-driven operations that enhance the productivity and responsibility. respectiveness, and establish real-time data sharing across the operations. IoT connects devices and systems, allowing seamless data exchanging and real-time collaboration to operate manufacturing workflow and decision making. Reduces waste, enhancing quality and improved efficiency. uh, Internet IoT things, it is reducing the human labor waste, enhancing the product quality, and it is improves the efficiency of the final product. IoT driven insights that help manufacturers minimize resources waste, maintain constant productive quality, and streamline processes for greater efficiency. Forms of block backbone of Industry 4.0. Industry 4.0, one of the backbone for manufacturing industry. It acts as a fundamental technology for Industry 4.0, supporting smart automation, interconnecting systems, and advanced data analytics. Suppose if we are taking our automotive industry, we are using most of the things, we are using sensors. For sensors, we need IoT technology, facilitating intelligent decision making using actionable insights. IoT processes real time data into meaningful insights, enabling manufacturers to make proactive data information informed decisions that drive innovation and competitiveness. Actually, what is Industry 4.0 overview? Industry 4.0 integrates IoT, artificial intelligence, robotics for smart manufacturing. It integrates three of them: IoT, AI, and robotics. Combines IoT, artificial intelligence, robotics. Industrial 4.0 revolutionizes manufacturing by enabling the intelligent automation, adaptive, productive system. Because of this, efficiency of our products increasing. Predictive maintenance also we are doing because of this one. You are saving maintenance cost. Focus on automation and connectivity and data analysis. Industry 4.0 emphasis automating process, enhancing the productivity between systems, and utilizing the data analysis to improve decision making and optimal efficiency. Enhancing the operational transparency and flexibility by leveraging the real-time data. Industry 4.0 product provides greater visibility into operation, enabling the flexible responses and dynamic production demands.
Sir, excuse me, sir. Sir. Sir, kindly make your slide into slideshow, sir.
Yes, sir.
Sir, kindly make your slide into slideshow, sir. It's not in slideshow.
I'm not hearing, sir.
Sir, your slides are not in slideshow, sir. Kindly make it to slideshow, sir.
No, okay, sir.
Yeah, sir. Thank you, sir. Sir, now it is okay, sir. Thank you, sir.
Okay, sir. Okay. The main core components of IoT, like sensor is main core component of the sensor gathers real data from the equipment and process. IoT sensor continuously monitor machines and workflows, collecting precise and real-time data to enhance operational efficiency and identifying the potential issues early. Sensors identify the issues and maximum sensors we are using in our mechanical manufacturing industries. Connectivity ensures seamless communication across devices. IoT relies on robust connectivity through networks like Wi-Fi, 5G, enabling the devices to exchange data seamlessly and collaboratively efficiently. Cloud performs store and analyze massive data. Cloud solutions provide scalable storage and advanced analytical tools to process and interpret vast amounts of IoT generated data efficiently. AI and machine learning algorithms drives actionable insights. The artificial intelligence and machine learning analyze IoT data, uncovering patterns, delivering the insights, support smarter and automotive decision makings. Cybersecurity framework protects sensitive information. One of the major problem is cybersecurity. Comprehensive security measures safeguards IoT system, ensuring the integrity and confidentiality of the sensitive operational and production data. IoT enabled smart manufacturing. Real-time monitoring optimizes manufacturing process. IoT optimizes the manufacturing process. IoT enables continuously tracking of production operations, identify inefficient and it will continuously observe the production operations and it will identify the inefficiencies and ensure the optimal performance through real-time adjustments and insights. It will adjust optimally. Predictive maintenance reduce unexpected breakdown. Due to IoT predictive maintenance, we can reduce the unexpected breakdowns. IoT powered predictive models forecast equipment issues, allowing the timely maintenance to prevent costly and unplanned disruption. It will notify the maintenance priorly. Based on that, we can maintain as soon as possible. Improve efficiency and minimize resources waste. IoT tracking tracks energy usage patterns, implementing strategies to reduce consumption, material waste, contribution sustainable manufacturing process. It will minimize the consumable material waste, all material wastages, it will minimize. Automates routine tasks, boosting productivities. IoT driven automation streamlines respectively tasks, freeing up human resources for more complex and high value operation. It will minimize the human work. We can use humans from another place instead of this. If you make automation, we can use human workers for other useful works. Enable adaptive production strategies. IoT system adapt to change demands, ensuring flexible and efficient production workflows that meet market and customer needs. All final products should be satisfy customer and market demand. Role of data in IoT manufacturing. Data provides visibility into the operational bottlenecks. IoT system collect and analyze the data, identifying inefficiencies and bottlenecks in the process. It will identify the inefficient ones, enable the manufacturers to address them proactively for smoother operations. Enables predictive models for operating for optimizations. IoT data power predictive models that forecast the process outcomes, helping the optimize workflows to prevent distribution before they occur. It will optimize the problems before it will occur. Facilitates the data-driven decision making across the operations. By providing actionable insights, IoT supports informed decision making, ensuring strategic choices that enhance operational efficiency and productivity. It enhances the final efficiency and final productivity. Real-time data monitoring enhances the efficiency. Continuous monitoring also through IoT, it will enhance the efficiency of the product. Continuous monitoring through IoT enables instant adjustment, production improving response times, and maintaining constant operational performance. Unlock new opportunities for innovation and growth. IoT insights reveals trends, potential areas for innovation, driving to the development of new products, process, and market opportunity. it reveals the potential areas, what are the potential areas, and what are the market opportunities, what are the customer demands. It reveals applications of IoT in manufacturing. Smart factories leverages IoT for interconnection system. IoT integrate machines, devices, processes in smart factories, creating a seamless and connected ecosystem that improves the efficiency and flexibility. It improves the ecosystem, that improves efficiency and flexibility of the products. Real-time tracking ensures supply chain efficiency. IoT enables real-time monitoring of material goods, streamline supply chain operations, reducing the delay of inefficiency. In IoT supply chain, real-time tracking also very useful for the materials and goods streamlining. Energy monitoring reduces operational costs. IoT system tracks energy usage, identifying inefficient and optimized consumption patterns, helping manufacturers lower energy costs and improve sustainability. Advanced robotics and automotive repetitive tasks. Generally, robots will do repetitive tasks. IoT powered robots enhance productivity by performing repetitive tasks, precision tasks with high speed and accuracy, reducing human errors. Definitely, robots will reduce the human errors and accuracy and precise. Remote equipments monitoring enable predictive maintenance. IoT facilitates remote monitoring equipment, identify potential failures early, enabling the proactive maintenance to minimize down. Instead of the shutdowning of the machine, it will notify the potential failures prior to the downtime. IoT predictive maintenance. Maintenance is one of the major things for our manufacturing field. All manufacturing machineries we have to maintain timely to get higher efficiency. Sensors continuously monitor equipment health. Sensors continuously observes the equipment health. IoT sensors tracking the equipment performance in real time, ensuring constant monitoring to detect anomalies to maintain operational stability. It will analytics predict potential equipment failures. Advanced analytics process sensors data to forecast equipment issues, allowing timely interventions before the failure occurs. Before failure occurs, it will notify. Reduce time, downtime, and extends the mission lifespan. If we are using IoT, it is notifying the failure before. You can maintain timely. You will enhance the lifespan of the mission. IoT-driven maintenance strategies minimize unplanned downtime and prolong the operational life of machinery through proactive care. Saves the cost by preventing unplanned repairs because they are notifying clearly. Instead of before breakdown, we are maintaining the machine. We are saving our money and efforts. Timely maintenance based on IoT insights prevents expensive emergency repairs, reduce overall maintenance cost, increases workforce safety through proactive measures. IoT system identify risks early, enabling the measures to mitigate hazards and create safer environment for the employees. IoT in quality assurance. In manufacturing process, one of the important thing is quality of the product. How IoT useful in quality assurance monitoring something. ensures constant product quality with the precision monitoring. IoT sensors tracking production process in real time, ensuring adherence to quality standards maintained constantly across the batches. It continuous sensors are observing continuously the quality of the products. Identify defect early using sensor data. Defect product automatically identifying using sensors. IoT system detect ana- anomalies in production using sensor data, allow manufacturers to address defects promptly before they escalate. AI-driven systems improve the process control. Artificial intelligence analyze IoT data to optimize the process parameter, ensuring better control and efficiency in the production flows. Reduce waste to smarter production in techniques. Reduce wastage. IoT insights enable precise adjustment to process, minimizing the material waste and promoting sustainable manufacturing practice. It will reduce the material wastages. Enhances the customer satisfaction with high quality of the product. By giving high quality of the product, we have to satisfy our customer. Constantly delivering superior products through IoT driven quality control assurances, improved customer satisfaction and loyalty. IoT and supply chain management. Track inventory and shipment in real time. After supply chain management also one of the important factor in our manufacturing. IoT enables continuously tracking of inventory, shipments, providing real time visibility and ensuring better control over the supply chain management. Improves delivery accuracy with location data. It improves delivery accuracy, fast delivery. Using like GPS, we can add. IoT devices use GPS, location tracking, monitor shipments, ensure the precise delivery schedule and reducing the delays. By if we are attaching GPS, we can deliver on time. Enhance the demand forecasting using IoT insights. Product demands also we can customer need. IoT data analysis predicts demand trends, allowing manufacturing to optimize inventory levels and align the production with market needs. Based on the customer need, we have to analyze. Reduce stockouts and overstocking issues. It is also the IoT system optimizes inventory management, ensuring right amount of the stock available to avoid shortage or excess surplus. Right amount of stock available and minimize the shortages and excess surpluses. Increasing overall supply chain management transparency, IoT provides a clear view of supply chain activities, improving collaboration, accountability, and operational efficiency across the all stakeholders. IoT for energy efficiency. Monitors energy consumption patterns in real time. Sensors are monitoring continuously. The IoT sensors track energy usage, equipment, and process, providing actionable insights, identify inefficient and optimize energy consumption. Using sensors, inefficient ones we are identifying and optimizing the energy consumption. Optimizes equipment to reduce energy waste. IoT enables systems adjust equipment settings automatically, ensuring optimal performance while minimizing unnecessary energy use. Okay, it ensures optimal performance while minimizing unnecessary energy use. Implementing automated energy saving strategies. Even we can implement automatic energy saving strategy. IoT integrates smart automation to control energy intensive process, reducing consumption during non-peak periods with manual interaction. Non-peak hours at right time, we can save the energies. Lower operational costs through efficient energy use. where if you are using energy efficiently, definitely the operational cost will be lower. By minimizing energy waste, IoT helps manufacturers to cut utility expenses, contributes cost effectiveness operations, supports sustainability goals with cleaner practices. IoT promotes sustainable manufacturing by reducing carbon footprints, optimizing resources, and encouraging energy efficient practices aligned with environmental standards. IoT in robotics, IoT driven robots. Robot equipped with IoT sensors adapt to environment. IoT enables robots use sensor data to dynamically adjust the changes in their surroundings, ensure optimal performance, derives manufacturing conditions. Collaborates with human work for safer operation. IoT powered robots with work alongside with humans, leveraging real-time data, enhancing safety and improve productivity in collaboration environment. Robots will work with human interference. Increase production rates constantly. Using production rates, IoT-driven robots streamline process, achieving higher production speeds with constant quality, reduced errors. Because of robot, automatically the production rates will increase with minimized errors. Because human interpretation is less, the quality of product also no standards. Monitor real-time data for performance optimization. Robot equipped with IoT system continuously analyze the data to optimize their functions, ensuring efficiency and reliable operations. Reduces human intervention in repetitive tasks. Definitely, a robot is a multifunctional reprogrammable device. What are the program we are giving? Simply, it will use for pick and place operations. Repetitive tasks, human necessary. Human we can. IoT enables robot automatic repetitive process, freeing workers, freeing our humans. So we can use human workers for other useful works we can use. For more strategic and creative roles, improved overall workflow of the efficiency. IoT in production monitoring tracks mission performance and production rates. IoT system monitors mission activity, production output in real time, enable the manufacturers to access and optimize the performance. It observes the production rates and efficiencies. Provide real-time alerts for operational deviations. IoT devices send instant notification for inefficiencies, allowing quick corrective action to maintain operational continuously. It will give alerts, deviational alerts and inefficient, anything minor problem also it will notify us. Ensure smooth workflow with optimized resource usage. IoT driven insights enable efficient allocation and utilization of resources, ensuring uninterrupted balanced workflows. Enhancing decision making with comprehensive dashboards. Real-time IoT data visualized user-friendly dashboards, providing actionable insights for informative and effective decision making. Improves overall equipment efficiency. Definitely, production monitoring in IoT, it improves overall equipment efficiency. It will improve. IoT enhances the overall equipment efficiency by maximizing the equipment availability, performance, and quality, driving higher productivity and reduced downtime. Because we are using most of the machines using IoT machines or sensors, it will notify the breakdown clearly. That's why downtime will be less. It will be improve overall efficiency. Challenges in IoT adoption. The main challenge in the IoT adoption is the initial investment is huge. The small manufacturer companies cannot afford this initial investment, and lacking of professional trained persons also, very limited people available, professional trained person. This is the main challenges in the IoT adaptation in our manufacturing industry. High implementation costs hinder small manufacturers. The significant upfront investment is required for IoT infrastructure. Like IoT infrastructure, IoT missions are more costly as sensors, software makers. It is challenging for smaller manufacturing to adapt these technologies. It is very, very difficult to adopt these technologies for the smaller manufacturer people because of the high initial investment, and after initial investment also properly skilled persons also not available. Small maintenance also we cannot do using the. This is the major problem in the IoT adaptation. Data privacy and security risks concern stakeholders. This is also another problem because of the cyber security. These all data privacy also major problem in IoT adoption. Huge anonymous data you will get. IoT system generates vast amount of sensitive data, raising concern about unauthorized access, breaches, and compliances with the data protection regulations. It is a major another problem with the adaptation this technology. Sensitive data we cannot uh, requires skilled work for IoT system management. It is one of the biggest problem is required skilled workforce. Professional workforce is needed for this. IoT adaptation necessitates a trained workflow capable managing, optimizing complex IoT system, creating a skill gap in many organizations. Limited interoperability across device. The lack of standardization in IoT protocol results in compatibility of challenges between the devices and platform, complaining integration effects. Dependence on the stable connectivity infrastructure. IoT relies heavily on robust, stable internet connection. Any network distribution can hinder the performance of the and reliability of the IoT system. IoT data analytics converts raw material into reliable insights. The IoT system process vast amount of raw data. It turns into the meaningful insights that help manufacturers to make the informed and impactful decision. Raw data it converts to meaningful and impactful, meaningful and manufacturers to make informed, impactful decisions. AI-powered analysis, predict trends, anomalies. Artificial intelligence, IoT data to identify pattern, predict future trends, detect the problems before they impact the operations. Identify the patterns, predict trends, future trends, and detect the problems before impact the operations. Enables the real-time decision making across the operation. IoT analytics provides instant insights, allowing manufacturers to make quick, informed decisions to address operational challenges efficiently. Improves efficiency with data-driven recommendation. IoT generates recommended optimized workflow, reduce inefficiency, and enhance the productivity by leveraging the real-time and historical data. Definitely using IoT, we improve the efficiency of the product. Support strategic planning with the historical analysis. IoT system achieve the data enabling in-depth analysis of past performance to guide long-term strategies and improve decision-making process. IoT and workforce productivity provides workers with actionable insights for better decisions. IoT system empower workers by delivering real-time data-driven insight, enabling them make informed decisions, improve operation outcomes, enhancing safety with real-time alerts monitoring. Safety also one more important point. IoT enhances device monitor workplace condition, providing instant alerts, potential hazards, enhancing overall safety of the employees. It will give alerts. It will give alerts with potential hazards to ensure the safety of the employees. Reduce manual intervention in repetitive tasks. Actually, manual interaction, repetitive tasks, most of them are doing by robots to reduce manual interaction. IoT-driven automation minimizes the need manual handling repetitive process, freeing workers more strategic and valuable added tasks. We can use that workers for more valuable tasks. Upskills workforce for advanced IoT tools. The adaptation of IoT necessaries training the employees, equipping them with skills, leveraging advanced tools, technologies effectively. Actually, we have to give training for the skilled persons and effectively these new technologies. Enables collaborative environments through connected devices. IoT forecasts collaborative by connecting devices, workers, facilitating seamless communication and teamwork across the manufacturing operations. One of the major thing is cyber security. Because it is generating huge data, we have to think about security of our data. Protect sensitive data from unauthorized accesses. IoT secures measures prevent unauthorized access to sensitive information, ensure data privacy, safeguard operational integrity. Protect sensitive data from unauthorized sources access. IoT security measures prevent unauthorized access to sensitive information, ensuring the data privacy safeguards operations. Monitoring network for vulnerabilities in real time. IoT continuously scan for the security weaknesses, enabling timely detection, mitigation, potential threats. It's ensures compliance with industry regulations. Definitely, it should follow the design, it should meet the industry rules and regulations. IoT solutions are designed to meet regulatory requirements, ensuring legal compliances, building trust among the stakeholders. It should be follow the regulatory requirements of the industries and legal compliances. It should follow. Safeguard the system from the cyber threats. It should give protect from the cyber threats. IoT security framework protect devices, networks from malware, hacking, and other cyber threats, ensuring uninterpreted and secure operation. Okay, it should be give protection from the malware like hacking and cyber threats. IoT in customization enables flexible production for personalized products. IoT allows manufacturers to adapt the production lines for customization, meeting individual customer preferences without compromising efficiency or cost. It should not compromise the efficiency, it should not compromise the product quality, and it should not compromise the material cost. Adjust the process in real time to the customer demands. IoT system dynamically modify the operation based on the real time feedback, ensuring the swift response to changing the customer requirement. Anyway, we already studied in our design process. We the every product, the customer satisfaction is main in our manufacturing industry. Based on customer feedback, we have to modify the product according to the customer need. Reduces lead times with the smarter workflows. IoT optimizes production workflows, minimizing delays, speeding up delivery to meet tight schedules, market demand. Monitoring product quality for constantly. For our ultimate aim in manufacturing industry is the quality of the product we should not compromise. IoT sensors track quality metrics during the production. Sensors continuously will track the quality of the product, ensuring constant product standards, reducing the likelihood of defects. Improving customer satisfaction with tailorable solutions. By enhancing the customer customization and maintenance, high quality IoT helps manufacturers to deliver personalized products to enhance the customer satisfaction and loyalty. Any manufacturing industry, the customer satisfaction is more important. Then only we can sell our products or we can produce our products. IoT's role in sustainability reduces energy and resource waste. IoT optimizes the process to minimize energy consumption, material waste, prompting cost effectiveness, environmental friendly manufacturing practices. It is very good for our environment, because as well as if we are reducing material waste and reducing energy consumption and final product cost also we can reduce. Promoting circular manufacturing with smart recycling. IoT facilitates efficient recycling and reuse of materials, supporting circular manufacturing models, reducing environmental impact. It is also very good for environmental impact, reusage of the material and recycling of the material, supporting circular manufacturing models and reducing the environmental impact. Tracks carbon emission for compliances. IoT system monitors and report carbon emission in real time, helping manufacturers adhere to environment regulations and sustainability standards. Environmental regulations, rules and standards. That's why we have to continuously monitor carbon emissions in real time. Encourage renewable energy sources integration. It is also a very good idea. We can use renewable energies like solar, biogas. IoT supports use renewable energies resources by monitoring usage patterns, optimizing energy distribution and manufacturing operations. Supports sustainable production goals. IoT aligns with manufacturing process with sustainability of objective, reducing environmental footprints and driving long-term ecological benefits. It aligns with manufacturing process. It is meeting its objectives and reducing environmental effects and deriving with long-term goals or long-term benefits. Case studies in IoT manufacturing. Automotive real-time quality monitoring enhances safety. IoT ensures precise monitoring of automotive components during production. identifying the defects early, enhance the safety and reliability. It is monitoring automotive components during production, identifying the defects early to enhance the safety and reliability. Electronics, IoT tracks, system tracks assembly process in electronic manufacturing, minimizing the defect, ensuring high quality product output. It is identifying the defects early and ensuring the high quality product output. Pharmaceutical monitoring storage conditions for safety, where they are storing storage conditions also we can check. IoT monitors temperature, humidity, and other conditions in pharmaceutical storage. We can all pharmaceuticals, most of the pharmaceutical storages, the main thing is temperature, low temperature. We have to store pharmaceuticals. The monitors temperature, humidity, and other conditions in pharmaceutical storage, ensuring compliances with the safety standards and preserving the product efficiency. Food ensures freshness with IoT sensors. IoT enables sensors monitoring food storage and transportation conditions, ensuring freshness and reducing spoiling throughout the supply chain. It is also one of the important tasks for food storage and transportation conditions. Freshness, it is checking. Textile IoT sensor streamlines textile dyeing operations, reducing water, chemical, energy usage, supporting sustainable and eco-friendly practices. Features of IoT in manufacturing. AI and IoT integration drives autonomous operation. The combinations of AI and IoT enable self-regulatory system, automating complex operations, reducing the need human intervention in manufacturing. Nowadays, AI is reducing human intervention in everywhere, not only in manufacturing, in every world, it is reducing. 5G enables ultra-fast and reliable connectivity. 5G network enhances IoT systems with high-speed, low-latency communication, ensuring seamless data exchange and improved operational efficiencies. It is giving improved operational efficiencies. Blockchain secure supply chain transparency. Blockchain technology integrated with IoT ensures tampered proof data tracking, enhancing visibility and trust across the supply chain. Edge computing reduces data processing latency. Edge computing process IoT data locally, reducing latency and enabling faster decision making critical manufacturing operations. Smart factories evolve with the continuous innovation. IoT foster innovation, integrating advanced technologies, enabling factories adapt, improve, lead competitive manufacturing landscape. IoT deployment strategies. Start small with pilot project for scalability. You can start with small pilot project. Begin with a small IoT implementation to test feasibility, identify the challenges, scale the gradually for broader manufacturing operations. We have to start initially with small as a pilot project, test the feasibility and what are the challenges we are facing. We have to identify and scale the gradually. We can improve. We can enhance the operations, manufacturing operations. Partner with IoT technology providers. We have to make MOAs. We have to make an understanding with IoT technology providers to make like collaborations. We can make collaborators with experienced IoT vendors to access latest technologies, expertise, and support for seamless deployment. It is very good idea. Actually, we can make collaborations with them. we can learn latest technologies from the experts, ensuring workforce training on IoT tools. We can attend trainings from equip employee with skill and knowledge to manage, optimize IoT effectively, ensuring successful adaptation. Because if you want to start the IoT deployment, initially some skilled persons we need to manage the equipment. Implement strong cyber security measures. Potential hazards, we have to cyber threats, firewalls. We have to protect from that. Prioritize robust security protocol to protect IoT network data from the cyber threats, ensuring safe and reliable operation. This is one of the most important point. We have to protect our data from the cyber threats. Regularly evaluate system performance for improvements. Continuously monitor and access IoT system performance, making necessary adjustments to enhance the efficiency, addressing emerging challenges. Continuously you have to monitor and IoT system performance to enhance, to improve efficiency, as well as to have to observe the challenges. Impact on global manufacturing. Increases global competitiveness through smarter systems. IoT empowers manufacturers with intelligent automation and data-driven insights, improving efficiency and positioning them as a leader in the global market. Enhancing collaboration across the supply chains. IoT system enables seamless communication and coordination among the supply chain partners, fostering transparency, improving the operational efficiency. Reduces dependency on manual operation. Automation means it will be manual interaction, which will be limited, reduced. Automation driven by IoT minimizes reliance on the human labor, manual labor, reducing errors, increasing productivity across the manufacturing operations. If we are using automation, automatically we will reduce human errors and we can reduce human labor, human force. We can use that human force for other useful works and increase the productivity as well as efficiency. Enable rapid adoption to market changes. Real-time IoT inverse, allowing manufacturers to quickly adjust the production and supply chain strategies, staying aligned dynamic market environmentals. We have to adapt the market challenges and market demands. We have to identify, and we have to adapt our technology as per the market demand. It drives industrial growth with innovation practices. IoT fuels innovation by integrating advanced technologies, supporting the development of new products, process, business models for the sustained growth of country. The conclusion: IoT transforms manufacturing with data-driven insights. IoT enables real-time data collection and analysis, revolutionizing manufacturing operations with smarter and more informed decisions making process. Predictive analysis reduces downtime, enhances efficiency. IoT-driven predictive analysis forecasts equipment failure, process inefficiency, minimizing the downtime and optimizing the production. Because predictive maintenance is very useful in IoT because it is notifying the error before it occurs. Smart factories promotes sustainable and innovation. IoT forecasts sustainable practices, drives innovation by integrating advanced technology into the interconnected and efficient smart factories. We are integrating technologies, manufacturing technology with Internet of Things and AI. challenges require strategic planning and robust system. And this is also one of the crucial overcoming IoT adaptation challenges like cost, security, demand, careful planning, skill force, and secure scalable systems and cost to like security threats and skilled workforce, professional workers also needed. These are the major challenges. Initial investment is huge, we cannot afford. The future holds limitless potential for IoT driven manufacturing. As IoT evolves, it promises endless possibilities from autonomous operations to advanced AI driven manufacturing, innovations shaping uh, the future of the industry. Thank you very much.
Thank you, sir. Thank you, sir. Participants have any questions? You can ask now.
Hello, sir.
Yes, sir.
Myself, Dr. Manish, working in CPET Jaipur as assistant professor.
Okay.
Sir, nowadays the production is becoming customized. No mass production. So how it is difficult to make a IoT in customized production. I use AI because for that it requires a lot of data, and in customized every data will be different.
Okay. Yes, sir. It is future technology. Hello.
Yes, sir. Participant is online only, sir.
Sir. Hello.
Yes, sir, I'm listening, sir.
Yeah. Parent, can you repeat one more time?
I am asking that nowadays the production is customized, shifting from mass production to customized production in anything, anywhere.
Hmm.
So, for my knowledge, for AI or the data machine learning, anything that more data is required. So, how it is going to help in the customized production for like a data
Yes, sir.
manufacturing?
Actually, we are in initial stage. The quarter in future, everything with AI and machine learning only. Traditional machining, we can use traditional machining, but in future, everything with the AI and machine learning only. Future is running with AI and machine learning only. We have to adapt the new technologies.
Any other questions from participant side? We conclude, sir.
Okay, sir.
Thank you, sir. Thank you for your presentation. I invite Mr. Vignesh, sir, to give out of thanks for the session number 9.
Sir,
Thank
I
you.
request you please share the slides, sir, of this session.
Sir, any queries, sir?
Share
I
slides
just
up.
request
He
to share
needs,
the slides.
you can share the slide later, sir. I think you have my slides.
Yes, sir. We will share afterwards, sir.
Okay, sir. Okay.
Thank you, sir. Thank you for your insightful session on IoT in manufacturing, leveraging data for smart manufacturing. Your expertise and explanations have truly deepened our understanding of how IoT can revolutionize the manufacturing sectors. The case studies and cutting edge strategies you shared will undoubtedly help us embrace data driven innovations in our own work. We are grateful for your time and knowledge. Once again, thank you for an engaging and thought provoking presentation. Thank you, sir.
Okay, thank you very much, sir, for giving this nice opportunity. Thank you very much once again.
Thank you, sir.
Thank you, sir.
Stay connected for next session.
Moving forward, we are set to begin session number 10, which will explore AI and ML in Industry 4.0. The expert Dr. Pannisalam Ramasamy. So we aim to start promptly at 7:30. So I encourage everyone to stay tuned for another engaging session. So kindly stay online. So meanwhile, we play on videos which is related to the IoT and manufacturing. Please stay online.
Transformation. What's holding you back? Is it in the different systems that prevent design and manufacturing teams from collaborating effectively and efficiently? Like the highly automated yet very complex process of PCB assembly, or the box build process, where the manufacturing steps are more complex and the human operator needs more assistance. Or is it in the new product introduction, where you need to identify issues earlier to save time and reduce costs? And there is limited visibility between electronics and mechanical assembly processes, with no feedback to improve the design. The result is one team not having visibility to what the other is working on. To overcome these challenges, you must use innovative solutions to ensure seamless collaboration across all teams. The question is, how? The best approach must provide a single source of truth for collaboration, data sharing, reuse, and control. In this way, distributed groups can work together to improve design quality and accelerate new time to market. Because seamless collaboration between design and manufacturing teams means continuous improvement and faster resolution of manufacturing defects earlier in the process. And by connecting the silos between electronics and mechanical teams, they build the products right the first time. You will know what needs to be made, how and where to make it, and the resources needed to deliver better products faster. The Siemens Smart Manufacturing is not just a concept or an idea. It's real solutions that deliver real results for manufacturers today. Envision the future of electronics manufacturing today with Siemens Digital Industries software. Siemens.
Welcome to Teralytics. Join us as we explore how AI revolutionized the optimization of IoT devices to drive industry platform. While IoT technologies offer immense potential for optimizing operations, it is crucial to every industry to take a strategic and holistic approach in data collection process. Instead of merely accumulating vast amounts of data, need to focus on targeted sensor deployments that align with specific operational objectives to save cost and manage easily. Artificial intelligence plays a crucial role in optimizing data collection from IoT devices by helping manufacturers choose relevant data while minimizing cost. Here's how AI can assist in this process. Identifying key performance indicators. AI algorithms can analyze historical and real-time data to identify the most critical key performance indicators for manufacturing operations. By analyzing patterns, correlations, and anomalies, AI can prioritize data that directly impacts productivity, quality assurance, maintenance, and resource utilization. This focused approach ensures that only vital data is collected, minimizing unnecessary costs. Predictive analytics. Through AI-based predictive analytics, manufacturers can forecast which data variables will likely yield the most valuable insight. By using historical data and machine learning algorithms, AI can identify data trends and patterns that are likely to contribute to better decision-making or process optimization. This enables manufacturers to collect data that provides the highest impact at the lowest cost. Real-time monitoring and anomaly detection. Monitor IoT device data streams in real time to identify anomalies or events of interest. By setting thresholds and using machine learning techniques, AI can filter out and prioritize data that deviates from expected behavior. This enables manufacturers to focus on data that indicates critical operational changes or potential issues, saving costs by avoiding unnecessary data collection. Dynamic data sampling and compression. AI algorithms can dynamically adjust the frequency and granularity of data collection based on contextual factors. This means that during periods of stable operations, AI can reduce sampling rates or apply data compression techniques to reduce storage costs. Conversely, during periods of higher uncertainty or critical events, AI can increase data collection frequency to ensure comprehensive visibility into manufacturing processes. By leveraging AI-driven approaches to data collection, manufacturers can optimize their IoT device deployments and focus on capturing meaningful insights while minimizing costs. It promotes data-driven decision-making, enhances operational efficiency, and empowers manufacturers to respond promptly and effectively to changing industry dynamics. Thanks for watching. Don't forget to subscribe for more content on the latest advancements in AI and manufacturing.
Good evening, sir.
Good evening. Good evening.
Shall we start, sir?
Yeah, you can.
Thank you for joining us, day 5, session number 10. So we are honored to have with us our esteemed speaker, Dr. Pannisalvam Ramaswamy, Principal Director, MSME Technology Development Center, PPDC, Agra. Now, to formally introduce and invite our speaker, I would like to request Mr. Sivashankar to take over this session, to introduce our speaker.
Good evening all. It is my honor to introduce today's distinguished resource person for the ATAL Sponsored Faculty Development Program, Dr. Pannisalvam Ramaswamy, Principal Director, MSME Technology Development Center, PPDC, Agra. With over 2 decades of experience, Dr. Pannisalvam has a strong track record in the implementation of ISO standards such as quality management systems, environmental management systems, and occupational health and safety. He is also highly proficient in Lean Six Sigma methodologies, which he has applied to enhance process efficiency and foster a culture of continuous improvement across industries. Beyond his technical expertise, Dr. Pannisalvam is deeply committed to entrepreneurship and innovation, playing an instrumental role in bridging academia and industry. He has successfully mentored several startups, particularly in the field of engineering and technology, and has been a driving force behind numerous skill development initiatives aimed at equipping students and professionals with the competencies required for the future workforce. Dr. Pannisalvam's contribution to teaching and curriculum design have also been pivotal, as he played a key role in developing programs that integrate entrepreneurial thinking with technical expertise. His work in data analytics further amplifies his ability to solve complex problems and lead innovative projects in both academic and industrial settings. We are privileged to have Dr. Pannisalvam Ramaswamy with us today, and we look forward to get benefited from his deep insights and extensive experience. Welcome, sir, to take over the session.
So thank you very much for short and sweet introductions. Am I audible? First of all.
Yes, sir. Yes, sir.
Okay, thank you. So to add to my introductions, I was also a member of committee set up by Government of India to implement Industry 4.0 among MSME sectors. So that's another additions I like to present to you. Then with this, thank you anyhow very much for the opportunity, and let me share my presentations. Presentation is visible?
Yes, sir. Slides are visible, sir.
What you can see?
Sir, AI and ML in Industry 4.0.
Oh, thank you. Thank you very much. So once again, I thank Mr. Dr. Raja for inviting me for this training program. He just wrote me a mail some few months back, and I acknowledge, and with the thanks. But I could see the lot of crowd in the forum, but I don't know who are all there. So for all the professors and the participants, faculties, guests, and invitees. And so good evening to everyone. So Industry 4.0 is sometime back, it's very popularly spoken, and the technology development among the industries. But adding to this AI and ML, the development of AL, ML, it's become more relevant now. I think that's going to create another revolutions. So most probably the tomorrow I will have another sessions, and we will elaborate it above. But to say something about AI, ML in industry 4.0 is really revolutionary in the future, manufacturing and productions. It's not just like ordinary things, but this industry 4.0 is popularly, practiced industry 4.0. But the same thing in America, they call it, see, they want to be a different, they want to show that they are, of course, they are first in everything. So they say that it is a smart manufacturing. So smart manufacturing and industry 4.0 is almost the same. No, when you say that is revolutionary things, so manufacturing became, smart, and smart manufacturing offers the smart services, smart products. That's what happening today. A smart product. The example, the simple example is, and so I am holding a smartphone is the smart product. It does everything. No one has imagined few years back, and the phone can do all these things. But purpose the phone, most probably people use it for communications, oral communications. But today, more than the oral communication, it works as many other device. People use it for, watching videos. That's became more. And of course, the oral communications has become very less. But if you see now, people use for WhatsApp, communicating the messages. But it is not a pager. It acts as a pager. No, it sends a video clippings, and people use this phone for sending the mails. I was, when Mr. Raja, Dr. Raja sent me the mail, I used the mobile phone to reply to him. So that's another. Then but the Hindustan films, I don't know what they're manufacturing now. So they used to manufacture the films, but today, so there is no camera using the films. So it's taken over by the smartphone. So use smartphone for making photographs. So there are many services which is very, very complicated services which can be dealt using the phone. Even people say that you can speak in English or in Tamil. Most probably, I am a Tamilian. So you are all, I think, mostly you are all Tamilians. You can speak Tamil very fluently, and the people, sometimes, when you speak other languages, you get struck or you get miscommunicate, or people may understand wrongly. But the same thing, when you got translated in the own language, so how it looks, it will look like nothing like that. When you listen in your mother tongue, so you will never mistake, and you will understand rightly. So you can speak in your own language. Suppose the Japanese who is attending the forum can understand in the Japanese language. That's what I want to say. You can communicate in language, but the another applications. That's oral translation in other languages. Even now, you can translate in any language you want. Some of the popular languages, you can convert it. So the phone, which supposed to do, phone means, and in the olden days used to have a oral communications, but now things have changed. It's become smart. It does everything, many applications. And so the popular phones, iPhone and Samsung, the new versions are very popular because it does many things. So this is what, a smart product. Another smart product we are all anticipating is a driverless car. I don't know what revolutionization it's going to bring. So when the bullock cart was, um, replaced by the cars, so there was a big revolution. So within a short period, everything is taken over. Many people lost job, and again, car has taken over. Similarly, the driverless car is going to have, it's another a smart product. So without driver, it's going to run. Most probably, it's going to be like a, computer on the wheel. Most probably, disrupt many things. The thousands of product by product, and the people who live on the business. So maybe you can imagine how many products are there in the car. So maybe thousands of products may be there. Again, the services, the many services, the travel service there, and you have service for maintenance service, and you have spare parts manufacturing. Many things it's going to be disturbed with the smart product like driverless. See, one of the largest employment in the world, drivers. So anyone who's not having much educations, so then they land up, they train and learn not driving and then land up with the job. But that's going to be disturbed. Then you can imagine what type of a revolution it can bring, the smart product. Again, smart services. So you will have, a wonderful medical services, most probably. The best doctors available in the world, when you talk about healthcare services. So you need not go to USA to get a, medical treatment. You can get a medical treatment, USA treatment in India. So most probably the sensors will work everything and communicate real-time data, and they can, tell you when you should go to your hospital and get it operated, or maybe when you are going to have a heart attack. So that type of a predictive analysis, it can, give. That's another trend it's happening. That means what I like to say is this new technology, Industry 4.0 is going to become a smart manufacturing, and also it's going to give us smart products, and again smart services like healthcare services, where you can most probably you can use a lot of sensors. I was just wondering, and when I came to read about the news, Google is purchasing or acquiring a sensor company. I was not understanding that time why Google is involved in a software, why they are going for a sensor company. Now afterwards I could see, now whenever I carry a phone, the phone is not working some type of video calling and other things. It will ask you whether you are driving. Are you driving? When you drive, it will not work videos because it senses that you are driving, and then it will ask you questions that are you driving. If you are saying yes, then most probably it will not allow you to play your videos. this type of sensors are in the mobile phone. So you can imagine what type of smart products the industry 4.0 is going to give. So there are many things going to come. But what ultimately is going to happen, that we will discuss tomorrow with the, see, another revolutions, industry 4. No, 5.0, 5.0, fifth industrial revolutions. So to understand to this extent, we have seen what industry 4.0 can bring it to us. But at the same time, we also should look back and see what, how this has happened, what type of technologies that have come on. So let us see the overview of Industrial 4.0 today. That's going to be the agenda of today's, and how this latest technology is going to be integrated. See, the cyber physical system of IoT. I think IoT lecture you had, and AI, artificial intelligence, and then ML, machine learning. So driving innovations, efficiency, and sustainability, how it's going to integrate the things to arrive, so innovation, efficiency, and sustainability in the manufacturing. This is what the main objective of today's session. So when you talk about Industry 4.0, so we have to recall the first revolution when people were not having any technology or mechanical machines. So man has invented almost 300 years back, 17th century. So 1784 first industrial revolutions. The looms were designed by the English inventors. That's where looms were designed, all our raw materials were taken to England. They used to have a raw material and then bring the finished product across the world, sell it across the world. So they used to make a lot of money on that. Then steam engines. I don't know whether you remember the history. The first, railway in India is 1953 from Pune to Bombay. That too, for transporting the textile raw material and textile goods, whatever they are importing, bringing it from British. That has brought some sort of mechanisms. So instead of using the shovel to lift the coal, they used some sort of mechanisms so that they can bring they can run the steam engines and then cotton spinning machines. And railways. Railway was invented still. I had an opportunity to go and visit London and London exhibitions, and it's where the old inventions are still they kept, and so they are very good in keeping old things. Only we don't have that type of attitude. They don't spoil old things, they preserve. So and 1870 second revolutions, the first conveyor belt. The conveyor belt saw a lot of automations. Automations means assembly line, making it very fast. At the same time, electricity to run the conveyor, and telegraph, fast communications, rail network, fast transportation, and gas and water, so produce the current to operate the machineries. So all these things happen. So assembly line became the mass productions. So they used to produce mass and then take it across the country, across the world, across the world, very fast, very fast. So mass production, so during that period, 1870, Then 1969, I think some of us are still alive, or maybe you might have, know, youngsters in the school. So third revolution took place with the electronic, mechanical, digital technology, mainframe computer. I still remember the Japanese calculator used to be costly 800 rupees. Now it is available for 500. Just imagine the inflation. But still, the better calculator is available for 500 rupees now. But used to, purchase and then use it during our, educations during our college time. So the electronic computer, mainframe computer, personal computing saw the internet space and research and biotechnology. So many technologies have come 1969 that makes more automations, robotics, electronic, So through electronic device, I think, because Triple E department is organizing the people mostly from electronic background, electrical background may be present in the forum. So you understand how this, engineering, helps to automate things. But now it's not alone will help you. Now it's became, once upon a time used to be a separate disciplines, but now separate discipline cannot do anything. Now it is, collaborating with others. It's all complement to each other. And so you cannot live with one knowledge or one field of engineering. See, you require a lot of, at least the working knowledge in many areas so that you can go with the automations and mass productions or communication, internet communications, and so then saw the latest today. Today is industry, of course, industry 5, fifth revolutions. We are in fifth revolutions. I'm talking about fourth is also existing. We are not seeing fourth. So when we see only, then we'll go to the fifth one. So in India, we are not seeing fourth revolutions yet. The particularly MSME sector, because I have a lot of experience with the MSME sector. Very few industries are there altogether. So you're not seeing fourth industrial revolutions. The advantage is good because fourth industrial revolutions had a lot of advantages and disadvantages. So when we are not completely, in fourth revolutions, so we don't get the full advantage and the same time full disadvantage. For example, and the Africans never saw the dialing phone. Only our people in India, we have seen dialing phones. Many places in Africa, I have not seen the dialing phone. They saw only the smartphone. So the phone means they understand only this. Phone means it has got all other smartness within this. So similarly, we are lucky that most of the countries in the world are not witnessed, except some few developed countries, completely fourth revolutions. That means except few industries in Germany, Europe, altogether Europe, then America, maybe other part of the world has not witnessed fourth revolution completely. So they have not got the disadvantage of fourth revolutions. And so we are landing up with the fifth revolution. So fifth revolution's got a lot of advantages over fourth revolution. It is only correction for fourth revolutions. I will discuss more on this tomorrow because today we will not have, tomorrow we will not have much to talk. So fourth revolution saw the big data. That means how to collect data and analyze data and get a real-time data analysis. Real-time data means just imagine a driverless car. How many things it is visual, videos. We have to collect, shoot the videos, collect things, and in a real-time data, you have to analyze and take decisions. So fast decisions so that you can take actions. So you have to activate the brake, or you have to keep side, recognize certain objects, recognize the signals. So this type of um, real-time data analysis possible now. So then comes Internet of Things. Internet of IoT has done a lot of things. Brought a improvement. So entire this automation, it happens through IoT. So that means suppose, when you have a internet, the people were talking. Now, machine can talk to the raw material can talk to the machine, and machine can talk to the machine, and raw material can talk to the raw material. So that's what happening with the invention of IoT. So suppose you want to manufacture a soft drink, what you have to do is you have to program in such a way, maybe using your all software skill, you have to devise the program in such a way that so you can operate automatically everything. So it will recognize the raw material, that bottle, and it will recognize the machines. The raw material, the bottle can go directly to the machine, and the machine can fill up exactly what the raw, no bottle can accommodate, and then can go to the next operations. That means it can communicate to the next machine. It can automatically go to the machines, and then it can seal, and it can be packed nicely, and it can go to the market. So everything is automated. So this IoT had done tremendous work. Has brought a lot of development in the technology. And 3D printing. I have very good experience with 3D printing. See, because the technology centers, we have few technology, 3D printing. So all kind of 3D printing. I have seen the sand mold 3D printing, core 3D printing. That means using a raw material as a sand, and then plastic, and then metal also nowadays possible. So this brings the time for design and evaluation, and very short. So you can bring the new product very fast. Suppose you want to launch nowadays, you have seen the smartphones are launched and every 6 months. The cars are launched every 6 months, and automobile products, maybe your two-wheelers, and the best thing is you can see the Japanese, not Chinese product. So a lot of innovative products are coming from China. So it's all possible. So you have an idea. So put the idea into the drawing and give the drawing to 3D printing. The 3D printing, the right type of a drawing, maybe not the two-dimensional, three-dimensional drawing, and which can recognize, and then it converts it into 3D form, and then print whichever material that you like to. So everything happens within a day or two. This used to take a lot of, uh, time in the olden days, conventional time. So this is brought innovation and bringing to the market, very fast. So 3D printing and cobots. So collaboration of robots, and see with the automations. So you can add an opportunity go to South Korea. Now Seoul, you can see a lot of cobots are available in the airport. Airport, wherever you want to go, you just tell or you feed the cobots. They will take you. You have to just follow it. Suppose you want to go to have a cup of coffee, so you just tell that I want to go to the coffee house. It will take you to the coffee house. Suppose you want to go to the check-in counter, so you have to tell the check-in counter for India, Chennai, then it will take you. Or maybe the airline. So Air India check-in counter, then it will take you to the Air India. So see the robots and big data analytics, real-time analytics, the IoT, all joined together has brought the network has brought industrial revolutions. Suppose you are producing, you are continuing to produce. You have some innovations, that innovation has got some disadvantage in a real time. And you will not know, but your automation and the machine and in the setup of a fourth industrial revolutions will go on producing. That's why we are going to have industrial revolution 5. That's the advantage we are going to get. Now we will see elaborating now. And so this now what we are witnessing is a cyber physical network. So integrating many things. What are the things? So, sorry. Yes. Just, yeah. So, I think before me, there was a lecture on digitalizations. Yeah. It all starts with the digitalizations. So, the industrial revolution starts, the first 2 steps you can see, it is the stages of industrial 4.0 development path. You can see here computerization and connectivity. That's what digitalization. It's all start with the computerizations. And then visibility is what is happening. You can see things are happening. The CNC machine, you can go and see what's happening inside. You are able to see and collect the data. Maybe in the form of operation, you are able to see visually, and then you are able to see the what type of a data that it generates by monitoring. You can see even your process control, whether it is in process or not, visibility, and whether you need to take some actions, corrections, whether it was required or not. And then understand what's happening. That's what I said. The second thing, first seeing and then understanding what's happening inside. Suppose CNC machines there, CNC machine continuously is operating automatically. We are able to see it. And suppose the dimensions are maintained or not, understanding. So that's what the second stage, understanding what's actually happened with the process. And what happen, it can predict. That's what now almost all products becoming smart. In developed countries, they are looking for a smart product. When it is a fan, they say that smart fans are available or not. When it is, warm appliances, a washing machine, whether it is smart machines are available. And what you will do the smart machines? It will predict when your washing machine is going to break, or washing machine will stop, or your fridge will have a problem, breakdown. So all the machine and your body is going to break down. The predictive capacity. So it will analyze the real-time data and then can reproduce what will happen. First is why it's happening. So then what will happen? So it can give you a predictive capacity, analyzing capacity. And then self-optimizing. How can I automate the response to be achieved? See, how can you give alarm? So maybe you can give an alarm that's going to happen. So go to the hospital, so and so, get it operated. Or they call your mechanic for, or not the calling mechanics. See, it will operate simultaneously lot of alarms. And so maybe the machine can communicate, and washing machine can communicate to the supplier, the service people, that so and so machine is going to be breakdown. So get ready to go to the machine and then set right. At the same time, it can communicate the customer that your machine is going to break down and your mechanic is going to come to. So you also will be ready. You can, in the process, you can improve your performance, improve the performance. So this is what all your industry 4.0 is. So that's why when and the committee, as a committee, when we started analyzing this, we suggested computerization and then connectivity. Computerization is the first things that you have to do, and connectivity, getting a data. So that itself involves a lot of things. So we are still in the process of 1 and 2, the stage 1 and 2. And then we will try to 3, 4, 5, 6. So we have very few industries have seen, 6, very limited. India. The same case with the other part of the world. So it is a better that you are not seen, because it's going to give directly, like Africans, they see a smartphone, the direct good things they are getting. So we are going to see the 5 industrial revolutions 5. And if you see the technologies that is involved in the 4.0, I think you might have seen, because you are I think Dr. Raja has done a very good thing, that in the gap some videos are played, so you will understand what exactly it is. So there are other technologies, lot of technologies, digital marketing results, then 3D printing for prototyping and the simulations. Nowadays, anything in the big companies, in the OE companies, they don't go without designing what it is. Once you design, then go for simulation. Simulation gives how the product is going to be, and you can see the real-time simulations on the screen. Maybe you want to do a machining, so you can understand how machining is going to done. So you want to mold a plastic component, so you will understand how the molding is going to be done in the mold simulations. You have to, even not only this, even skill enhancement, we started using simulations. You give simulations and then develop the skill. So many things in welding, so things are happening like that. industrial revolutions. I know IoT, I have already told you. Then robots, cobots, quality, comparing with the standards data. How you can, nowadays in the automations, and you get all the details of the quality on the screen, visibility. Some sensor technology. That's why I said sensors became so efficient. It can collect many things from your body and then communicate to the doctor. That's the way it works. What about other things? Anything you can get it. And analyzing the capacity to analyze the real-time data. That's so data means that's what people are afraid. See, one of the experts has said, how you are going to manage this data? Whether you have, the the facilities to analyze the data, store and analyze this data. That's another ground of research is going on. Many fear that the data cannot be stored and analyzed. The cloud data, of course, we have a cloud nowadays. We are able to do certain things, but still, it's very difficult. We used to have a very small free data old days. Now we have a 50 GB free or 100 GB free. So 1000 GB, 1 GB free. Then visual reality. This is another very big tool. You can, many people they use. It seems people go to go to the computer and select the product. Maybe you want something which is which gives a very better look for your house or for yourself. So you need not go to the jewelry shops. You can wear certain things and see. It will take a photograph and then most probably it will assemble whatever the ornaments you want, and then you can choose which is good, which is you look good. And augmented reality also, virtual realities. So it's many high technologies that's involved in 4.0. The overall benefit, it gives as automations. So you order something, it will go on happening unless you stop. It's not going to think anything else. There the AI tool works. The people are now want to use AI tool, artificial intelligence, machine learning, learning with the data, learning with the data. So otherwise, what will happen if it's gone automatically produced? Even the raw material is not correct. You are going to produce things, produce all bad products. That will happen. That's why now, so one human-centric approach. It's 5.0. Industrial revolution and 5. We will see it tomorrow. Role of AI and ML in industry. So I gave you small introduction already. Stimulates the human intelligence for problem solving and decision making. If you don't take a decisions, what will happen? You are going to produce continuously. Even the bad you are going to make, produce. You should understand that it's not matching with the tolerance, then you have to stop. Matching with the quality, you have to stop. That's what we require. And it's going to fail and you'll stop the entire productions. There is one more tool called, a very popular tool. I remember this now. 1, 10, and 100. I don't know how many of you heard about it. Suppose you take preventive actions it's a one-time cost involved. You take some preventive actions, then 10 times cost is involved. Suppose you take, you allow them to break down and then you invest, then it takes 100 times. So 1 10 100 rule. So if you don't apply the artificial intelligence, most probably every industries will have this 4.0 industry revolutions 4.0 is chances of having 100 times because it will break down. So to take this intelligence, artificial intelligence, your machine learning, a set of data, AI that use the logarithm to analyze and learn from data to predict the outcome and then suggest you the solutions. That's what I'm. So why important automation of a complex processes, enhance decision making, preventive analytics. Just imagine now. Yesterday I was reading a newspaper. Was surprising. Yesterday or today I don't know. The people today I think today. So people in good no Bihar. So they are more than 120 years. There are a lot of people with above age 80. That means the medical things are good. That's why people are living. So you are able to preserve their body. The habits are good, so they get more. The maybe now they have more attention towards preventive things than we have more years of life. So this is not a long time it's going to happen. It will happen not only in bigger states across the India. Maybe we'll also witness. Now people used to look at the Japan, how people live for a long time. Same thing will happen here. So AI and ML will give you such a facilities. Maybe not only the human body is also a wonderful machine. Wonderful machine, no? That's why I gave this an example. So it's going to happen in the same way. You will get all predictive analysis so that you can take corrections. You can take a corrections. Key applications. I already told you predictive maintenance, early detections of equipment failing using IIoT, industrial, IoT, and then machine learning. Machine language will help you to understand things. So AI and ML will help you to generate the informations that you need. So most probably, you will be able to see the real-time informations, immediate informations, so that you can reduce downtime and the repair costs. So you need not repair when it's not required. When you can postpone it, you can postpone it if it is good. That not necessarily, when you buy a car, people is after you. Even if you don't run the car, they don't leave you. Sir, if you don't run also, you have to do the service within 6 months. So I say that easy. I'm running the car very less. Why I should do it? Everything is okay. But still, no, sir, it has to be done in 6 months because those people are getting, money, repair cost. So that's what you require. So quality control. So you can detect and then, take actions. So even, image processing. So nowadays, in the olden days, we used to get a lot of mix up in the rices. You have seen the rice used to have lot of black rices. Nowadays, you are not getting it. How? This is because of quality control. So the quality control, visual control, the race, it deducts the black rice and separates it. That's why we are getting a good rices. And the black rices are, not mixed with the good rice. And even the stone, or other materials are, taken away. And then supply chain optimizations. What is required? Nowadays, of course, all automobile have gone and to Toyota manufacturing systems. So just in time, just in time avoids many things. Now, people are more conscious. So they want to reduce the time, only the delivery time, but also the cost. With the help of cutting the wastage. The wastage Toyota manufacturing system suggests this is 8, no, 7, they said 7. Now the human, unutilized human or human creativity using, if you are not using the creativity, then it's became a waste. So we have a lot of waste. That waste cutting is adds to the profit. Waste cutting adds to the profit. So demand forecast and inventory management. It's a big role in cost cutting and autonomous systems. So there is no, waiting period. So you make everything automated. So making it fast. So it's a fact. It became a smart factory, and smart factory delivers smart product. Yes, smart way the services. Energy optimization. And so all AI driven energy management. So wherever there is no, nowadays there are a lot of IoT, and even we could see small things. If people are not there, the light is switched off automatically. The energy conservations, energy optimizations. If it is not useful, you don't only go into idle mode. Even the computer, it goes into the sleepy mode. So such type of things possible only with the AI and ML in Industry 4.0. And customization. So that's becoming a big issue nowadays. So the mass production has gone. Everyone wants as a taste. Suppose you are 4 people in a family, then you have most probably, definitely you will have 5 tastes. So see, the children will have 2 tests. Say if not this, that alternative, and only the most probably the father will have only 1 test. Whatever the test which is not liking by them, that test altogether forced by the another test, because he has to lead the family. Wherever that is there. Nowadays the situations are different. Even ladies also lead the family. So the same case. So mass, customization is happening. Every product, people wants differently. If a car, okay, I want car height is so much from ground level. I want, the seating arrangements like this. I want the color is like this. Are many things the people, they have a different type of a taste. So they go for, made for me product. That means the product is made for me. Like you go to the tailor and stitch a tail in the olden days, and it is not fitting. Nowadays, people are more conscious about the body, and they use advanced technology, understand what is the standard deviations and average, and then produce mass, 42 inches and 44 inches and 40 inches. So similarly here, but mass customization is happening. So that's not there. You go and give exact your size and get tight fitting. So right fitting. Tight fitting is not the correct word. Maybe a right fitting. So the same thing is happening with the industrial field. Mass customization is happening. So AI, plays a very big role in, no, some of the applications you can see examples. Aviation, GV aviations. I have collected some of the informations. GV aviation uses the AI forward, predictive analytics to monitor the jet engine performance. This approach has significantly reduced the unscheduled maintenance events. So you can imagine. So if they spend a lot of money on the scheduled maintenance, saving millions of dollars. Suppose everything is okay, you need not go for, the Siemens implements the predictive maintenance for its gas turbines. The sensors track operating conditions, and machine learning predicts the potential failure, reducing the downtime to 30%. So I think you all know what gas turbine does. Gas turbines are most probably the powerful gas turbines are used with the electricity generating. So when 30% downtime, saving, reducing the downtime is 30% downtime cost, is the profit. So you are going to generate that much extra power, and then you get. So reduce unplanned downtime by 70% with the AI and ML, and low maintenance cost up to 25%. 20% increase the equipment lifespan. So enhance the workers' safety. Safety of the workers also you can enhance. Prevent, unexpected failure. Suddenly, suppose your crane is going to have a failure. If it is a smart, crane, then it will give an indications that is going to fail. Maybe it not only give to the operator, it will give to the beneficiaries. Sometimes it will give an alert system of things, so everyone get alerted, get a precautionary message, they can be ready. So the safety is taken care of. Automotive vehicles. Telsa leverages the AL and ML for self-driving technology, enhancing the lane keeping, obstacle deductions, and the route optimizations. Most, the application is the supply chain optimization. So another big, area, supply chain optimization. And so example, Ford uses the AL for real-time supply chain visibility, optimizing the inventory levels. Ford is, they are very much worried about the waste because, and the healthcare, the medical device manufacturing. So some of the devices use the ML algorithm to ensure precision in implantable devices like pacemaker, application, the predictive equipment maintenance. So, and then please integrate the AI in a medical imaging system to predict the maintenance needs and avoid equipment failure. And during clinical operations, something fails at the clinical operations, what will happen? It's all happening. Suppose you are doing some, operations, art operations, suddenly some, medical device fails, what will happen? So the life has gone. You cannot afford to have such kind of failure. So the AL and ML can and really can help you to get the preventive signals. General Electric uses the AI to optimize energy distributions in the smart grids, reducing the energy loss and balancing demand. Energy loss is a big demand again. You all know the electrical people, right? I am a mechanical engineer. I can say only with the experience. So the electricity department, they do not know how things are happening. Electrical loss. This again, applications, energy applications in plants. Shell employs the AI-driven monitoring system to optimize the refinery process and reduce emissions. And again, how retails can. Walmart uses the AI to predict, product demand and manage inventory. Again, so Walmart does many things, automations. Real-time industry 4.0 is working. See, even automation happening with the, and the system automations. Suppose Walmart has got many outlets across the US. See, they have a data, real-time data of what product, where it is sold, whom it is sold. So once the product reaches that level in the supermarket, the minimum supply level, they automatically generate the indications that it goes to the supplier. It generates the supply order. It gives to the supplier whom it should supply. So it should supply to the store where there is the demand. That means where the product sold more. So it automatically generates. No one attempt to generate things. It automatically see the level inventory and then generate an inquiry that this has happened. So Nike uses the AI customization product for individual customers. Suppose I don't like to have the common on the shelf. So I can put my demand. So I can have a individual, customized products. And agriculture, again, that's a very big field. Where you have a lot of course, in India it is very difficult because of our limited lands available. Lands are very small. Where there is a lot of lands available, you can use AI-based sensor and drones and for a crop monitoring and yield predictions and pest deductions, automated equipments, you can have many things. The tracks AI in tractors for automated seeding or irrigation and harvesting. So now you have to look for many things separately. Now we can integrate. And logistic and supply, route automation. Route automatizations can happen with the inventory management. So the travel is another big loss to the industry. Is one of the big loss. If travel is reduced with the optimization, then definitely that will help the industry to save cost, save that waste, and then improve the profit. the flight optimizations. Oh, flight optimization is another area where you can really look at it. So the same flight, and it's operating in nowadays. You have and maybe overstraining, because overstraining is the cause for many accidents. But optimization possible use of AI and ML. Rolls-Royce integrate AI with ultrasonic sensor to early detection of material defects in aircraft engines. So that's another because possible. Drug recovery, the discovery. So some of the medicine manufacturers, the pharmaceuticals units, uses the AI to analyze the millions of chemical components, millions of medical compounds for a new drug development. Yeah, plays a very big role in analyzing the compound. So maybe it is DOE, design of experiment. So some manufacturers uses the ML to optimize pharmaceutical manufacturing process, ensuring the quality and compliance. Then coming to food and beverages. Yeah, I was surprised. I was watching a WhatsApp video, the forward videos. So one guy has come out with the innovations of you can make anything. So you give all the ingredient to the machines. The machine then you feed and ask the machines to prepare something. It'll prepare for your taste. But you should provide all the ingredients. The PepsiCo uses the AI-based cameras to detect the product's defects during the package. The predictive maintenance. Nestle integrates the ML to monitor the performance of food production equipments. Again, in the textile field. So, no, I am just giving sector-wise example because you can understand better. So, automation in weaving. You all familiar that even one thread cuts, the machine stops automatically. Again, the one man can operate, many power looms. It's a very simple in our villages where power looms are there. You can see 6 or 5 looms are operated by one operator. H&M employs AI predict the fashion trends and adjust the production. Fashion trends accordingly. What type of a cloth are liked. Fashion trends. And what type of fashions people like, and accordingly we can make. The t-shirts. Not t-shirts. The fashion, I am just giving an example. Construction project. Construction projects, we have safety issues, big issues. Inventory is a big issue. So we can use AI and ML in no real-time monitoring. Caterpillar integrates the AI in construction equipment to prevent accidents by monitoring equipment and site conditions. Site conditions. Electronic, your own field. Chip manufacturing. The Intel uses the AI for deductions during the semiconductors fabrications. Smart device manufacturing. The Samsung's employs AI in the assembly of smart devices, ensuring a precision and quality. It's another area. Telecommunication network optimizations. It's possible. So Ericsson uses the AI predict analytical networks. Traffic management, reducing latency, applications customer support. And Vodafone implements the AI-driven chatbot for efficient customer service. Now, customer service are using the chatbots. And oil and gas, the pipe monitoring. So last, I think Iran and no, not Iran, Ukraine and the Russian war, the pipeline was broken. We all know that. So how it was broken? So they say that some sabotage. So we can monitor those things with AI and real-time monitoring of pipeline, identification of leak or potential failure. So we can detect, for example. So some companies leverage the AI for data analytics to locate oil and gas leakage. So there are, even in the service sector, it is possible. The banking, for example, monitoring transactions for, some of the fraudulent no transactions, you can use AI for identifying. So Bank of America uses its AI chatbot and to assist the customer with the account inquiries and transactions, account inquiry and transactions. And so suppose so today we have conducted the meetings, some people have paid amount, you want to assess how much you got. So you can use a chat box. So you can get those informations. Patient diagnosis, that's another very, very big important area. So where IBM Watson Health analysis medical records and suggests the potential diagnosis and treatment options. Now you don't require a doctor, it seems AI will do it after some time, most probably. Certain things, small things, not all, maybe. And the Teldoc Health uses the AI to provide a visual consultation and so this all happened during our COVID period. So this type of approaches, and Apollo Hospital employs the AI for efficient patient admission and charge. Yes, I was wondering in India, I go to the hospitals, you spend the whole day for a patient and just consultations. But in developed countries, I have my own experience in UK. See, the outpatient consultation is 15 minutes, not even 15 minutes. Everything done in online. So you do it and go to exact time and get things, intact and come back. That's what happening. So, and again in the education line, personalized learning. So people are, personalized learning very important. Coursera uses the AI to recommend courses tailor-made. Yes. So I have premium facility for LinkedIn. LinkedIn, I really invite all the people. Fairly, I'm good in LinkedIn. My ID is Dr. Pannirselvam Ramasamy. It is there in the. So I have around 22,000 followers. 22,000 followers. So people think that. So I don't know. So why they have come so much. So what happens? Those who have visited my LinkedIn profile, they can understand that I do a lot of courses on the LinkedIn. So whenever I have a free time, I do that. Or whenever I go for a walk, a simple time, I use the audios from LinkedIn. So a lot of things. So based on my learning, so LinkedIn continuously suggests, sir, this is the video been uploaded. Are you interested in learning this? It will suggest. So this all happens because of AI and MI. And retail and e-commerce. So Amazon uses the machine learning algorithms to suggest the product based on your browsing. Suppose something you browse in the Amazon to purchase, it will again it will give you indications. These are the products available. Lot of products, you know. So there are many applications like that. Even they use chatbots to assist the customers to select industries. No, beauty products. Beauty products. Walmart uses the AI to adjust the prices in real time based on demand, competition, and inventory. So one more thing I have seen in the travel industry also. So you click and you search for the um, some route. So you may be getting a less rate. So immediately after some time, again, no immediate first attempt you may not do it. You may not book the ticket. The second attempt to try, definitely that rate will be higher because it understands that you are particular in fixing that particular flight, particular time, no particular day. So it will give you more price. And even hotel industries. The Marriott uses the AI to personalize the guest experience, such as room preference or special offers. The chatbot for booking and entertainment content. The Netflix, suppose you open uses the AI to suggest movies. When I see some movie, detective movies, the next time when I go, I will get a lot of detective movies. So they suggest, since you have watched this movie, we suggest this type of movies. And real estate, it's not even a one single area it is left. Solo employs a ML model to provide accurate property price. And Compass passes the AI to match the buyer taste property based on the preference and budget. And legal services, another service. See, some of the legal company uses the AI to analyze and summarize the legal documents quickly as possible. As quickly as possible. You want this, you ask, he will give you. So human resources. The LinkedIn uses the AI to match the job seekers. So I get a lot of jobs. See, and suppose I look for the people who watches. I get the notifications that you have been appeared in somebody's search, and so and so visited your profile. See, all those type of, and you are most suitable for this type of jobs, or your liking courses are available now in the LinkedIn. So there are many things. So not even a single area is left out where AI and ML is not involved. So now it's a big role to play. The applications are enormous. The days to come, most probably you will have lot more, things to come, and most probably it will changes and disturbs many things, and most probably you will have all smart services, smart products, smart. Other day I was discussing with one of the industry fellows. Then they asked, sir, how to select the walls smart, design walls smart walls. And see, I have seen this as when I visited Korea. See, you go to the restroom, that means you are, your restroom attached with your stay room, attached with the room, you can find a lot of smart things are attached. Lot of smart. So everything is becoming smart only because of AI and ML. So it's not even left one. So I think I have not given and some examples in the insurance company. Insurance also we use a lot of things and logistic and transportation and consulting and services. So there are many applications, many applications possible through this. So you know the key applications and importance of AI and ML in industry 4.0. Otherwise also, so as I told you, industry 4.0 has not come fully. So we are with the first two steps, computerization and digitalizations. So that's not happening, completely. So, but other things, the invasion of AI and ML is happening in almost all areas. Not it has not left a single area, So it has got a great scope for industry 4.0 or otherwise also. See, that's what I said. India and the global MSCs are almost the same level on industry 4.0 adaptations. There is lack of awareness, and again, at the 6 to 8 month huge progress made. That means when and no, this slide I have taken from our the committee slide. So this some of the things, data are being copied from the committee who was implementing the ISO, no sorry, industry 4.0 with the MSME sector. So driving technologies. Internet of Things already happening. The sensors are become very efficient. So collecting the real time data. I seen the smart products like a watch. So the technologies are um, so driving the industry 4.0. So now the AI and ML technologies are driving the industry. Computer vision, so another big area where so AI are there. Then real challenge implementing AI. Now I think this data quality and quantity. This I told already. And the best example is just now it happened to me. Our data is not, I am not able to open my, no video because of this problem to give better, no bandwidth. So data quality and quantity, why it's a big area. So we are not, no able to, bring in. And even not only in India, it is a general things everywhere. Then just imagine if driverless car comes, how much video, datas and the videos will be generated and how this is going to be manipulated. So then the integration, compatibility with the legacy systems. And the initial cost, high initial cost, where we are going to pitch in, because there are many poor countries still able to get the basic things. How we are going to, we are no, I just put up the old world into this. Of course, the developed countries are finding it difficult. So involve the high initial investment and then skill gap needs for trained personnel. Professional requirements very huge in this area. How we are going to match? This is another challenge in implementing AI. It takes data privacy. So still, I know we are not able to give. No. So even our Aadhaar card we are not able to. But when we are giving Aadhaar card at a bank account, the people are afraid that. So sometimes people can, hack the account. So these are the big challenges that we have today. So data is another big area, and integrations another area. Then initial cost investment to bring all these technologies together. That's another big, challenge, and skill gap. I don't know how much we need to, because just imagine, and the highest number of employees in the world is car drivers. That means drivers. If driverless cars are come, the smart products, how disruption is going to create, you must just imagine where you send these people. So how the people, will manage? You need to upgrade the skill. Those type of issues, no prevails. It's all a big challenge. Then real world examples. I already mentioned this. The predictive maintenance for turbines and AI driven manufacturing for autonomous bodies, AI watch houses, robotic and supply chain, and AI for engine performance analytics. All these things. The future trend, how it's going to be. I know it's going to be a big, good news for AI people. AI at the edge for faster processing. Yes. Collaborative robots, the cobots, and the human machine collaboration. So that's what we are going to see tomorrow. It's a big area, another big area we are going to have. Then green AI for sustainable manufacturing. So this is a future trend, because when you are using industry 4.0, so it cannot be a green. That means sustainable manufacturing. It can generate a lot of environmental problems. So that the automations may not understand that. So you have to use the green AI most probably to have a sustainable manufacturing. So AI-driven innovations, use the AI and create the new business model. New business model. Most probably, the days are not very far off. You ask AI, that means your artificial intelligent tools, so it can suggest you a business, profitable business in electronic city. If you ask, then it will give you some, trend. No, I am in electronic city, I use it. Maybe Chennai. Nah,
Sir, your voice is breaking, sir.
voice is breaking. No, I have a network problem, I think. What about now?
Now it is clear, sir.
So AI-driven innovations is going to have many, areas. Each and every areas, almost in all, field of engineering, we are going to witness the AI-driven innovations. That's another trend. And so anything, it can give. Now also it's possible. People say that chat box you use, chat GPT use, you ask for anything, a letter draft, it will give you many models. There are AI tools available. You ask them to ask for a logo, design a logo. They will design the logo, and not only one, they can design many logo. You can choose as you want. Letterhead, the simple examples. So same thing, product also you can do. And focus interest. This I have again taken from where the MSME committee. See the members, task force members committee slide. Though some of the automotive, so automotive some of the sector focus sector I have noted down here. There you can see there are many left out also, but immediately maybe we can use certain field. So metal forming and forging, machine tool, heavy machineries, leather, footwear goods, textile and apparel manufacturing, aerospace, defense, pharmaceutical, medical devices, and capital goods, and chemical and petrochemicals, electronic system design and manufacturing, IT and tourism, hospitality service, food processing, transport. All this, will have almost everything is there in the focus area. So I have just, we have also given some examples to the government that what is the amount of saving or improvement that we can bring in. So Sansera Engineering Bangalore, there's one industry, it's brought 30% benefit improvement in productivity using AI, simulation of production system and manpower utilizations, only 2 areas. So they used industry 4.0 in only 2 areas: production system, stimulation in production system, and manpower utilization. So 30% improvement. That means 30% production if you increase, you are increasing the profit. Sparkonic Pune, 20% reduction in design time, duplication and retrieval of data. So wherever there is a design, many people don't go for a design only because of this problem. They don't. All delays happen because of the design department. That's my experience. I had an opportunity to be the general manager of Indo-German tool room, where they used to design tool and then produce plastic injection molding tools, forging tools. There are many tools they used, foundry tools, forging, foundry, and plastic. So, but always he used to blame the design department. This type of arrangements definitely it's a great help. And reduce material by 6%, improved controls on cleaning and temperature. 6% material, that means you straight away increase the profit. Karnataka Engineering, 30% reduction in cost, data storage and duplications, 30% reduction in costs. So 30% profit, that means. Energy Wind Bangalore, 50% faster delivery of product. Faster energy management, 3D designing instead of 2D. And Yumon Kala, Finland, that's a Finland, foreign, not our country. 20% increase in production. This again, productions with the IoT, utilization of a cloud service, data analytics and reporting. So you can have an idea that minimum 6 to 30%, 50% we get advantage in using AI and ML tools industries. So now some of the developed countries where they are, so in which area they are experts. So you can see France, 2015 they brought in the funding, of course, mixed funding. They invested a lot of funding. That also we suggested. These countries, they have been using this type of funding. So industry, production base, MSME and mid cap. So target audience. Then Germany 2011. Germany is one country where you can see a lot of industry 4.0 manufacturing. That means smart manufacturing, mixed cyber physical system and IoT. So very much. And then Italy also a generic, and Netherlands, yeah, mixed, generic, and Spain, funding. Who gives funding? This is the public funding, the mixed, and the public digital platform, big data, and collaborative. Spain industry above all SMEs and micro enterprises. Yeah, small enterprises also there. Our MSME like that. So Sweden, it's a general and mixed funding. So UK mixed funding area, aerospace, automotive, chemical, and nuclear and pharma. The business and industry research organizations, the target audience, those are there. And Singapore is another country where you can find a lot of improvements in industry 4.0. So this application, as most probably they say that it has, it has almost improved the life of Singapore itself. Not only in the manufacturing area, it has increased it's improved the city. It's become a smart Singapore, smart city, smart city. And again, it is ready to support Indian initiatives. That's what we suggested there. So ready to support Indian industry. Challenges, I think this we have discussed. Anyhow, I have a lot of. Again, so you can see the website. We have discussed with them. Anyone who wants to have some, contact, they can go to the website and then get in touch with them and really find out what happened with them. So to become competitive, definitely this industry 4.0 is very handy and it's required tool. So what are the areas we can reduce manpower, dependence on key persons? Sometimes, that's very great weakness for industry. You depend on some key person. Skilling in new areas, that's also possible. And improve capacity utilization. It's another big challenge. Say you can really solve the no capacity utilization and downtime. And material tracking. Material, really no industry, they have a tracking of material systems. It's a very poor tracking system. For that, we can use AI and ML. And the method process, innovation in design. So the big area, energy efficiency, quality, another big area where we can really think of using AI. Again, marketing, improve visibility at a reduced cost. And compliance to regulatory and government guidelines. Sometimes you miss. See, suppose pollution control problem is there, they will close down the factories. So for that we can use the money, visibility of financing cost. So many people they run the industry, they do not know what's happening inside. So then ultimately they end up with the big loss. So all these areas we can use, AI and MI tool to make it, more efficient. Am I audible correctly? Hello, sir.
Yes, sir. Yes, sir. You are audible, sir. But
Okay, very good, very good, very good.
time
That's why
exhibit.
I put up my So some of the areas where the benefits achieved. So the people who implemented Industry 4.0 has got increased productivity 51%, and provide better data for 47%, increase competitiveness 46, lowering manufacturing cost 44%. That means manufacturing cost straight away add to the profit. All these things at increased profitability 42% of increase. You see the investment, but it increased the profitability. Increase the process capability 39%. Increase the innovations 35%. Increase in factory, so 32%. Increase product customization. So this, there are many advantages you have. So you can get it from the source also we are given. So anyone interested for more informations, you can refer to the source. QCI is the Quality Control of India. Benefits of AI and ML in industry, efficiency, to make it very short. It's efficiency, faster, error-free process. So error-free towards zero error. That means you are reaching almost a Six Sigma status, the process improvement. Faster means you can supply services or a product and faster rate. Scalability, seamlessly adaptation to production changes. You can immediately adapt to the production changes. Cost reduction, optimize the resource utilizations. So we can use, resources. So to use very efficiently. So decision support. So real-time data-driven insights. You can get immediately the insights of the data. So whether we are running profitably or whether incurring loss or we are going to have a problem, all those real-time data, just now data, just in service, just in time service, we can call it as just in time service. Then innovations. So you have no depth for the innovations. So new products, solutions via AI-driven R&D. R&D, there are the different tools available with the R&D. And conclusions, of course, and AI and ML are the central to the industry success. So without that, it's very difficult to achieve. So invest in AI capability. That is the call to action. Upscale workforce. So you have to upscale workforce. Workforce has to be updated, or upscaled, and adopt Industry 4.0 technology. So start with the computerization and then visibility. So that's our 1, 2, 3 steps. And the closing note is the future of manufacturing lies with intelligent automations. See, automation, but it should be intelligent automations. That's what I like to call as a closing note. So this is what all about my presentations. So thank you very much for present learning. Now we'll go to we'll go to the question and answer sections. I kept the question and answers for now 14 minutes. 15 minutes I want to keep, but I kept 14 minutes. Any question and answers you can ask if you have. So thank you very much. Thank you, Raja Sahab.
Thank you,
So
sir.
you can initiate.
Thank you for your informative session, sir. Any questions from participants? You can unmute yourself.
I think so. They are very clear, or they have not clear.
The session was very interesting as well as it is very clear to everyone, sir.
Mm. So thank you. Or we are late our sessions.
Yes, sir. Let me conclude the session. I invite Mr. Sivasankar, Assistant Professor, Department of EEE, to conclude the session.
Hello, sir. On behalf of everyone present here today, I extend our deepest gratitude to Dr. Pannisalam Ramaswamy for sharing his invaluable insights on the topic AI and ML in Industry 4.0. Your expertise and presentation have enhanced our understanding of how AI and ML are transforming industries and inspired us to explore new innovative approaches in our fields. We sincerely appreciate the time and effort you took to be with us today and impart such meaningful knowledge. Your contribution has undoubtedly enriched our program and will have a lasting impact on all of us. Thank you once again, sir, for your outstanding session, for being such an integral part of this FDP. We look forward to more such opportunities to learn from you in the future. Thank you, sir.
Thank you very much,
Thank you, sir. Thank you.
Raja sir and all others.
Thank you. Thank
I think Manish has raised the
Yeah, we will.
hand. You talk to me or raise the questions. You have clarifications. I am ready to do it, though it has been no closing note is over.
Yes, sir. Thank you, sir.
Yeah, please go ahead, Manish sir.
Tomorrow we'll meet, sir.
Please. It's okay.
Thank you, sir.
Oh, okay. Thank you very much. And so we'll meet tomorrow,
Yes,
same time.
Yeah,
No,
for the last.
time I think. Now tomorrow is little early, first hours.
Yes, sir. Yes.
Oh, thank you so much. Tomorrow I have another session also, so it is better that I have before that. So wonderful day to everyone. So nice weekend. All the best. Thank you very much. Bye.
Thank you, sir. Thank you, sir. Thank you.
I can leave.